Hello grade 9s, my name is Natasha Barton and I would like to welcome you back to the video on Exponent Law 2. This is part 2 of the videos on this law, and I'd like to remind you at this point that Law 2 is the law that says that when you are dividing powers that have the same base, you're going to subtract the exponents. The first problem says, simplify 16x to the power of 7 divided by 2x to the power of 4. The beauty of this problem is that it contains coefficients, those numbers in front of the powers. And that means that we need to deal with the coefficients as well and simplify them as far as possible. The beauty of coefficients is that they follow normal integer rules, and since we are dealing with fractions, we will simplify the fraction here as far as possible. If you have a fraction 16 over 2, you would simplify it by finding the highest common factor of 16 and 2, which is 2. We divide the numerator by 2 and we divide the denominator by 2. This brings us to 8 over 1. Now that we have dealt with the coefficients and simplified them as far as possible, we can deal with the rest of the expression using our exponent laws. Since we are dividing powers that have the same base of x, we know that we will be using law number 2. X to the power of 7 has a higher or larger exponent than x to the power of 4. So we will therefore move x to the power of 4 up and subtract the 4 at the top, so that we end up with x to the power of 7 minus 4. We can simplify this and we end up with the answer 8x to the power of 3 over 1, which is exactly the same as 8x to the power of 3. And this is the final answer to this problem. The next problem says simplify 3y to the power of 5, z to the power of 3, divided by negative 12, y to the power of 3, z to the power of 7. Let's start off by dealing with the signs before we move on to the coefficients or powers. We have a positive term being divided by a negative term. Positive divided by negative is negative. Now that we are done with that, we can take a look at the coefficients, which we now know follow normal integer rules, and because this is a fraction, we would like to express our fraction in the simplest form possible. The highest common factor of 3 and 12 is 3. So we therefore divide the numerator and the denominator by 3, and we end up with 1 over 4. Now that we have dealt with the coefficients, we can deal with the powers and use law number 2 to simplify this as far as possible. The first type of base that we see is y, with y to the power of 5 having the bigger exponent. So we would like to move y to the power of 3 up into the numerator, and we then subtract the exponents. So we have y to the power of 5 minus 3. We then have the next base being z, with z to the power of 7 having the larger exponent. So here we would like to move z to the power of 3 down, because in the end we would like positive exponents. So we have z to the power of 7 minus 3, and this takes place in the denominator because we are moving z to the power of 3 down into the denominator. If we simplify this further, we end up with negative y to the power of 2, because 5 minus 3 is 2, and 1 times y squared is y squared, over 4z to the power of 4, because 7 minus 3 is 4, and grade 9s, this is the final answer. This next question says simplify negative 7 q to the negative 6 r to the positive 5 divided by 21 q to the negative 4 r to the negative 3. This is a rather interesting problem because it contains negative exponents. So I would like to encourage you to pause the video at this point, try this question yourself and see if you get the same answer as I do. Now here we are dividing a negative term by a positive term, so we know that dealing with those signs first, we will end up with a negative answer. We can now move on to the coefficients. We have a fraction and we would like to have this fraction in the most simplest form possible. So we look for the highest common factor of 7 and 21. This highest common factor is 7, and if we divide the numerator and the denominator by 7, we end up with 1 over 3. Now grade 9s, to ensure that we don't try to do everything at once and that we don't make silly mistakes along the way, I'm going to write out everything else exactly as it is in the initial expression. Now we have a 1 in front of q to the negative 6. We know that 1 times q to the negative 6 is simply q to the negative 6, so I'm going to remove that 1 to ensure that we end up with the answer in the simplest form. We are now going to use our exponent rules and definitions to simplify this expression further. I am going to be making use of the definition that you can see written on the right hand side of your screen, which says that 1 over x to the negative m is equal to, or means exactly the same as, x to the positive m. Those terms highlighted in the denominator, I would like to move up to the numerator and make the exponent positive. So we now end up with q to the negative 6. We move up q to the negative 4, so we multiply by q to the positive 4. We have already r to the positive 5, and we now move up r to the negative 3 so that it becomes r to the positive 3. Now the 3 that was initially in the denominator will stay there. We do not move it up with the powers because the negative exponent is not on it. That is a coefficient. It stays in the denominator. Now we are multiplying terms, so we know that we should use law number 1, which tells us that when we multiply powers that have the same base, we add exponents. So on q we have negative 6 plus 4, which gives us q to the negative 2. For r we have 5 plus 3, which gives us r to the positive 8. And we write this over 3. We have done nothing with that 3, but we still write it down. Now you will notice that q has a negative exponent. When you have negative exponents, it's an indication that you have not yet simplified as far as possible. So we need to deal with that negative exponent. And the way that we deal with it is by moving that term from the numerator into the denominator, so that in the end, the final answer to this problem is negative r to the power of 8 over 3 q to the positive 2. This is the final answer to this problem. Before we end off this video, I would like us to try one more problem. This problem requires us to use law number 1 and law number 2. We have a fraction that we need to simplify as far as possible, and we are multiplying in the numerator and multiplying in the denominator. So let's start off by multiplying or simplifying the numerator as far as possible and doing the same for the denominator. When multiplying, we look at law number 1, which says when multiplying powers that have the same base, we add exponents. Here in the numerator, we also have coefficients. So we remember that we deal with coefficients just like normal integers. We multiply coefficients when we are multiplying. So we therefore start off by saying 2 times 1 times 4, and that gives us 8. We look for like bases, starting off with m. We have m to the power of 4 and m to the power of 3. So we add these exponents and obtain 7. We also have a p in the numerator, but that is only one term, so it stays p to the power of 2. We can now go ahead and simplify the denominator as far as possible. We are still using law number 1, and we remember that when multiplying, we multiply coefficients. So we start off by saying 4 times 3 is 12. We have an m in the denominator, but there's only one term containing m, so it stays m to the power of 2. There is also a p in the denominator, p to the power of 5 times p to the power of 3. So we add those exponents and end up with p to the power of 8. Now that we have simplified the numerator and denominator as far as possible, we can go ahead and divide. And we remember that when dividing, we make use of law number 2, which says that when we divide, we subtract exponents of powers that have the same base. We also remember that when we divide coefficients, and if our term is in fraction form, we try to get that fraction in the simplest form possible. As coefficients here, we have 8 over 12, and we need to find the highest common factor of 8 and 12, which is 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So in its simplest form, 8 over 12 is 2 over 3. Now we can use law number 2, and we look for like bases and subtract their exponents. The highest exponent on m is 7, and that is in the numerator. So we bring m to the power of 2 up into the denominator by subtracting that exponent. We have m to the power 7 minus 2. On p, the largest exponent is 8. So we bring p to the power of 2 down into the denominator, and we end up with p to the power of 8 minus 2. We can now simplify this expression further, and we end up with 2m to the power of 5, because 7 minus 2 is 5, over 3p to the power of 6, because 8 minus 2 is 6. And grade 9s, this is the final answer to this problem. This brings us to the end of this video, grade 9s. Thank you so much for joining me. I hope that you will join me in the next video, in which we will explore law number 3. Also remember that to retain all of this knowledge, you need to practice. So remember to download the worksheet and memo off of the Junior Turkey website. Thank you so much for joining me, grade 9s. Keep well.